Hi all, Tony from Immortality. Now we hear people using the buzzword cure aging, but what about actually curing aging for real? What evidence is there that aging can be cured, and how would one really go about curing aging? Well, it appears that some animals have already cured aging. They are biologically immortal. For example, the crab, the lobster, said to have negligible senescence. Lobsters grow by molting, which requires considerable energy, and the larger the shell, the more energy that is required. Eventually, the lobster will die from exhaustion during a molt. Older lobsters are also known to stop molting, which means that the shell will eventually become damage infected or fall apart and they die. Tortoises are believed to be able to slow down the aging process. At 190 years old, Jonathan the Seychelles giant tortoise is thought to be the oldest living land animal in the world. That some animals live longer than humans show us that the biological limits are not yet reached, and humans could be able to live as long as the giant tortoises. Planaria potentially live indefinitely, cured aging and are biologically immortal. Hydra, cured aging and are believed to be biologically immortal. And of course, Tortoises dornii, the immortal jellyfish. Animals like newts, zebrafish are termed model organisms because they exhibit fascinating abilities. So how do they cure aging? It is called regeneration. These model organisms act as a proof of concept that aging can indeed be cured. We know it's possible only if we are able to adapt it to human beings, if we copied it and applied it to humans. The mechanisms of their amazing ability to cure aging involves maintaining embryonic-like stem cells, telomere maintenance, and maintaining a high-quality cell scaffold called the extracellular matrix, and of course, activation of the specific parts of the genome required for regeneration and maintenance using chemicals and electroceuticals. In contrast, we are not flying blind that some cure will magically appear somewhere in the research as a natural, inevitable result. The proof of concept is an important point to make. The billions spent on curing aging and age-associated disease may lead to nil, for no proof of concept or clear path can be provided that the research will ultimately lead to a cure or even what a cure looks like. At Immortality, we not only talk about regeneration, but human regeneration, and imagine a system of regeneration applied to humans as an ongoing clinical therapy. The ability of the human biology to perform regeneration of tissue and organs so that their age and, more importantly, their condition and function remains ideal regardless of time. Observations show that humans have an identical ability of regeneration, but get this, it is switched off in the genome, not genetically expressed, and gets locked away soon after birth. A fraction of regeneration that is not switched off is called self-repair, and humans have the ability to self-repair. Self-repair is a limited regeneration. It is believed that without self-repair, human beings would barely live for 5 years. But with full generations, humans would not age at all, and that aging is the inability of the organism to maintain itself. With aging, even the self-repair system becomes increasingly turned off and no longer performs crucial maintenance roles. Therefore, the path to cure aging in human beings is to unlock human regeneration. Here we illustrate regeneration when it is still active in an infant.
When Tommy Palmer was 5 months old, he caught a viral infection that got into his brain. The results were devastating.
When we first got to hospital, he was just lifeless, just sleeping.
Laying in your arms, sleeping.
Laying in your arms. And if
Wasn't
he did,
feeding.
No, if he did wake up, he was just crying all the time.
Tommy had suffered a stroke.
When you hear it, you think,
You just
oh,
don't-
he's had a stroke, that's it. You think he's not going to
worst.
be able to walk, he's not going to be able to use one side of his body, his face is going to be dropped. You know, you think the worst.
This is Tommy's MRI scan. Each picture represents a slice through his brain and his face. The white patch on the right of the scan is the stroke damage, a massive part of Tommy's brain where the cells have all been destroyed. If an adult had a stroke that big, it would leave them permanently damaged. Believe it or not, Tommy began to recover within days.
This is like astonishing.
Yeah, they hadn't done anything.
No.
He was just recovering himself. They hadn't actually done anything, only looked at him.
Doctors can do nothing to fix this kind of brain damage, but Tommy's body seemed to be looking after itself.
I just wanted to see, you know, what he does with two hands, whether he passes things from one hand to the other, what he can do with his left.
3 months after the stroke, when he was assessed by a physiotherapist, the only sign of damage was a little weakness on his left-hand side.
It's a good boy.
Oh, brilliant. Good.
But just 3 months after that, Tommy is hardly affected by the stroke at all.
He's 11 months now, and he's just improved.
He go?
From being basically a lump of meat in your hands, not doing nothing,
Lump of meat.
to what he is now. You know, he's just...
A lump of
Well,
meat.
he was, wasn't he? He wasn't doing anything. Nothing at all. And, like, to see him now, it's brilliant. If you didn't know he had a stroke, you wouldn't know by looking at him. I don't believe you would. It's fantastic, isn't it?
No one understands what went on in Tommy's brain to make him recover so quickly. Conventional wisdom says that Tommy recovered because other, healthy parts of the brain took over the work normally done by the damaged part. But there's a doctor in Boston who thinks that something much more important is going on.
Now the next thing I want you to do is turn them so that like you're going to be catching rain in the air, okay?
Evan Snyder's passion is the brain.
Way up, way up. Okay?
He works as a neurologist in the Children's Hospital in Boston, and seeing children recover rapidly from strokes like Tommy did convinced him that something remarkable goes on in children's brains.
Just like spaghetti.
Inspired by what he saw on the wards, Snyder went looking for an explanation. And what he found was a type of brain cell that behaved like nothing he'd ever seen before.
We could start with a single cell and then over time see a dish filled with cells that look just like a whole brain. It was as if we were watching a recreation of the brain right in front of our eyes.
Tony, over and out.